Hello everyone and welcome to the episode 2 of Machine Learning with R, a really fantastic journey. I'm Hamid Reza Abul Hassani, PhD of Computer Engineering, researcher, Chief Data Scientist and founder of DataBox. I'm very happy to see you again in this episode. So, as you remember, in the previous episode, we focused on regression, on machine learning with R. The first lesson was regression. We have solved a simple problem of linear regression. As you can see, hopefully we will go based on these methods of machine learning, and then we will go to deep learning. So now we will go to clustering and especially k-means. In this episode, we want to focus on k-means algorithm. Okay, so let's quickly start. What is the clustering and what's the purpose of clustering? So as the name tells to us, we want to cluster some data, and it is very helpful in some classification and many other examples and applications that I will show to you. So we will use several great references here that I will also share with you in the descriptions. First of all, starting with this really great reference from MIT, Massachusetts Institute of Technology, which was really great, and you can also find it on the net. So here is about clustering. So here you see that it's related to unsupervised learning. As you know, machine learning is consists of supervised learning problems and unsupervised, like this. Supervised means if we have label for the data, but here in unsupervised learning problems we don't have a label. So for example, here we have some data like this and some like this, and we want to cluster them. Okay, but we don't know at the first time that what are their labels. Okay, so let's quickly review the fundamental concepts, because in my opinion, I believe that in artificial intelligence and machine learning, if we don't have a deep insight about the concepts and fundamentals, we cannot go very successful and have some great results. Okay, so let's start. So what is clustering? The organization of unlabeled data into similarity groups. So we want to find the similarity. Yeah, these similar groups names clusters. So the first things we want to see that these similar groups are called clusters. A cluster is a collection of data items which are similar between them, and this similar to data items in other clusters. So you can see, for example, here the red ones are in cluster 1 and the blue ones are in cluster 2. Yeah, yes. Okay, also this one a little harder clustering problem. We can see, yeah, this is C1 and this one C2. Yeah, and the history of historic application of clustering is described here. John Snow, a London physician, plotted the location of cholera deaths on a map during an outbreak in 1850s, and it was the problem. So the clustering came from here. Also some computer vision applications, image segmentation, you see. Yeah, in some image segmentation. What do we need for clustering? So you see that similarity measure. We want to measure the similarity. Large if xj and xk are similar. Yeah. So here we see large D and a small s. Yes. Large D and a small and large S and a small d. Yeah. So this similarity or distance measure D. A small if xi and xk are similar. So D is a small if the samples are similar. So it's very obvious that if the samples are similar, so the distance are small. Yeah. Here we see a good clustering example. You see 3 clusters, C1, C2 and C3, and here is a bad clustering because we will see in the later that it's something like that is overfit. For example, it will make some problem for us that we will discuss later in deep. Okay. And here are the distance. How we measure the distances? It's we have some mathematics formula for measuring the distance. For example, Euclidean distance is measured and calculated by this formula. You can see also Manhattan distance, which the concept you can realize and find it very easily. It's not very complicated. You can see that we are subtracting these locations and to the power of 2 and some of them and the root square. Yeah. And here another thing, and another type is Minkowski distance. Yeah. So here are cluster evaluation method. We can see, and also you can see the details in the document. And we see, for example, here in the left side we have 3 clusters, and in the right we have 2 clusters. So what is the possible we see that fix the number of we can when we see in the following slides, at first we choose the k, the number of clusters, by ourselves, for example random or something. Yeah. So and we will optimize this number. Yeah. So these are the clustering techniques. We see that there are 3 clustering techniques: hierarchical, partitional, and Bayesian. Here our focus is on centroids, which covers k-means. Yeah, k-means. In this episode we will try to cover all other clustering techniques. So here are also the definition of each clustering techniques. For example, hierarchical algorithms find successive clustering using clusters using previously established clusters. These algorithms can be either agglomerative or divisive, okay, bottom up or top down, and also partitional. Partitional algorithms typically determine all clusters at once, but can also be used as divisive algorithms in the hierarchical clustering. And Bayesian. Okay, but here, as I told to you, in this centroid, in the subtype of partitional, we have k-means algorithms for clustering, which we will cover in this episode, and also the R codes for that. So what is k-means clustering? So it is as discussed, it is a partitional clustering algorithm, and let's see what is the mechanism. Let the set of data points D be x1, x2, and xn, where xi is xi1, xi2, and xir is a vector in x belongs to R, and R is the number of dimensions. So K-means algorithm partitions the given data into K clusters. Each cluster has a cluster center called centroid. K is specified by the user, as I told to you. So at the first time, the K is specified by the user. That I think maybe it's one of the weakness of this, in my opinion. Maybe you can also discuss and share your comments and ideas with me. Maybe it's one of the weakness of this algorithm, because it's I think it's better that that the user doesn't have any intervention in it. So K-means algorithm, given K, the K-means algorithm works as follows. Choose K random, as I told to you, choose K random data points, seeds, to be the initial centroid. So for example, we randomly choose K, for example, to 3, as the example of today is also 3, and we will choose 3 centroids for this cluster. Assign each data point to the closest centroid, recompute the centroids using the current cluster membership. If a convergence criteria is not met, repeat step 2 and 3. So we will optimize the location of the centroid to be in center of each cluster. Yeah. And it is the convergence that you see, like some other machine learning algorithm. We use sum of a squared error for convergence, for calculating the convergence, and these are the basic and theoretical concepts that if I want to go through them, it will take a lot of time, and you know that here we want to focus on the hands-on experience using R. But if you are interested, you can see and do some practice and also read the textbooks related to this. So here is the step 1. We see that the green ones are our data points here, and here the first time we set K to 3, yeah, and we see the centroid as C1, C2, C3. But you see these are not very optimized arrangement. So in that, yeah, we can see that here is a step 2. We see that determine cluster membership for each input, yeah, and then at the step 3 we re-estimate cluster centers. As you can see, we will move this C1 to this and this, and yeah, it will make it better. You see, yeah, we have some clusters here, yeah. And also second iteration, we will iterate this as much as we can find a very good result. Yes, so here I think you see a very good clustering. So why use K-means? It's simple, easy to understand, yes, really, and efficient. The time complexity is good and efficient, and also is the most popular clustering algorithm. Yeah. So, and note that it terminates at a local optimum if SSE, sum of a squared error, is used. The global optimum is hard to find due to complexity. And the weakness of K-means, yeah, the algorithm is only applicable if mean is defined. Yes, it's one of the weakness. For categorical data, K mode, the centroid is represented by most frequent values, and the yeah, as I also emphasize that the user needs to specify K. And also the algorithm is sensitive to outliers, which is not very good, but it is very popular for learning and also some doing some examples. Yeah. And yeah, you see it's sensitive to outliers. Yeah. Mhm. And it suggests us some solutions for dealing with outliers, like remove some data points that are much further away from the centroids and perform random sampling. Yeah, here is the sensitivity to initial seeds. And yeah, okay, I think it's good for k-means, and for the background is enough, and it's a summary that we already covered all. Okay, here is another document that is good, you can also review, but I don't go through them. It was valuable, so I wanted to show you and I will share with you. It's from Duke University, and it was also valuable and great. You see that it shows you the clustering, for example, another examples for clustering cats and dogs and mouse. You see, yeah, this is another example. You can see it's another point of view, and it's really also valuable to see, and another things that from their point of view. But for R, for data clustering R, which are really interested topic, and our purpose here is really nice tutorial and presentation, this PDF from Yanchang Zhao, from this document you see, and this website is really good. And let's see what we will go based on this document. Okay, so you see, already what is data clustering, but let's very quickly review this and make it a little, yeah. So data clustering is to partition data into groups where the data in the same group are similar. Yeah, we already know this, because at the first of this episode we have discussed it to one another, and the data from different groups are similar. Okay, to segment the data into clusters so that intra-cluster similarity is maximized, Yeah, and very important that the inter-cluster similarity is minimized. Yeah, and the group obtained are partition of data, which can be used for customer segmentation, document categorization, etc. So here is data clustering with R. Let's do the hands-on experience, which I really love. I really love R, and it's very joyful to work with it. So we will start with k-means clustering. Yeah, and then you see in the next episode we also will cover the other things. So the dataset that is covered in this episode is Iris, the famous Flower dataset by Frank and this. Since I don't know the exact pronunciation here, in 2010, consists of 50 samples from each of 3 classes. So we have 3 class of Iris, Flower, and in each class there are 50 samples. Yes. Okay, so yeah, there are 5 attributes in the dataset: sepal length, sepal width in centimeter, petal length and petal width, and also the class. You see, we have 3 classes based on this: Setusa, versicolor, and virginica. And sorry if I for some of the names my pronunciation is not exact. Please accept my apology. I just want, and I love to share what I have learned, and I love to share it with you. Okay, so here I also have prepared this from some data. You see that these are the 3 type of the flowers we see, 3 type of iris flower, and for each of them we have 50 samples, as you know. And this is the petal, you see, this is the petal, and this is the sepal, yeah. So this is the sepal and this is the petal, and the purpose is to, and we have some other data of this: the length and the width. Yes, the length and the width, yeah. So based on these data we want to cluster data. Okay, so what should we do? First of all, let's take a look at iris dataset. So first of all, new file, and then first of all we can put a question mark and then iris, and then control it. Yeah, here you can see when you put a question mark and a dataset, you see iris is a built-in dataset in R, and we see the description, for example, the famous dataset of Fisher and Anderson's dataset, yeah, and already this. And okay, and if we want to see some summary about it, yeah, it shows to us 150 objects of 5 variables, yeah: sepal length, sepal width, petal length, petal width, and species. Okay, so another thing here is, yeah, we have, because for any problem it's better first of all we observe a data set. The data set is really important for us to check it, to what are the types of data, how is the data what is the data shape, and something like that. For example, here if we want to check the data shape, let's see dimension of iris. Yes, yeah, it is as it shows to us 150 rows and 5 columns, yeah. Okay, so let's continue. So at first we will find a very great insight: 150 observations, records or rows, and 5 variables or columns. The first 4 variables are numeric, you see there are numeric, yeah, and the last one, species, is categorical. The last one is categorical, called as factor in R, yeah, yes, categorical, and has 3 levels of values. 3 levels, yes, 3 levels: Setusa, versicolor, and virginica. And you can also see here, yeah, 3 levels. It's this STR will give the really great information to us. Okay, so let's see. And also we can run summary on this data set. Summary to see, yeah, to see some summary of the data: mean, median, first quarter, and third, and also maximum we see, yeah. Okay, and here yeah, partitioning, k-means clustering. So we already have talked a lot but not enough about k-means clustering, but as you remember, we want to partition data into k groups. Okay, first I'm trying to improve the quality of clustering by moving the objects from one group to another. And you see that k-means is introduced in 1990 at first and at 1976 by McQueen, and also 1998 by Al-Sabti, and randomly select k objects as cluster and so on, as you remember. Yeah, these are the things that you can also read. Yeah, so let's see how it works. Yeah, these are some fundamental these are some theoretical concepts that we already talked about, and it is really nice that we can do. First of all, it has set the seed, because if we set the seed, our examination will have the capability of reproducibility. But here for me is not important, because I want to just see one time. So first of all, it will put the iris data set into iris2, because you really want to make a copy of it and do something. We want to do something on that, and we don't want to make some changes and modification on the main data set. So first of all, we will create this new data set or data frame iris2, and we will copy this iris to that. Okay, so nice. Here we have, let's check iris2. We see this, and you remember we can just iris2 head. You see. So because here we want to use the clustering, so it's normal, it's obvious and certain that we should remove these species, because we want to check, we want the machine learning to do this classification and clustering for us. So here the purpose of this code is that we remove the class of label species. Here we remove the class of and make it null. So let's do this. Species to null. It's case sensitive, so please be careful that we should take care of case sensitivity. So let's check again, head iris2. We see that the species is removed. So, and here we will run k-means on this data set, and we set the k to 3. Here we set the k to 3, as we also already knows that there are 3 clusters, but no problem, you can also set another thing, but here we will set the k to 3 because we just want to validate and check the the mechanism of this algorithm. So, and we will save the result and store the results in k-means result. So let's see, k-means dot result. Yes, k-means dot result, k-means iris2 and 3. Yes, so let's see what k-means result like. We see that k-means result, it has clustering with 3 clusters. You see these 3 clusters and clustering vector, and also some other information here. And this is the total SS is 88. Not bad. Okay, so here we saw the k-means clustering. And here is a very good thing to check the clustering result. The clustering results, again the class tables. Let's check them. We put table iris and species here. Iris species, yeah, because we already have the species and we want to compare it to iris 2 sorry, k-means cluster, k-means result, cluster, yeah, cluster, sorry, yeah. So we see that for the first one, Setosa, it's the accuracy was great. It's already almost 100% right. And for versicolor, not bad. And for Virginica, with some errors, you see. Yeah. So let's check another thing here. Yeah, class Setosa can be easily separated, as you see, easily separated from the other clusters, and others to a small degree overlap with each other. So here we will have a very great examination. We will have a very first of all, let's plot this iris 2 and check the yeah, first of all, this means that plot this iris 2. The first one, why is here is blank? Because it says that then all the rows, yeah. So here let me show you, when we put this blank, and then it means that all rows, okay, all rows, and just these columns, just sepal length and sepal width, okay. And the color here, col means colors, the assign the colors to k-means dot result cluster that we already have reached to it. Why I don't show you the down? Because it's really fantastic and I want to show you the result in the code. So let's check. I really enjoy and I really love R because of it's nice. It's very friendly. Plot iris 2, yeah, plot iris 2, and then here the first one means all of the rows, and here for the columns just sepal length and sepal, sorry, width, and here the color equals to k-means result, yeah, cluster, yeah. Let's check. Oh, sorry, we have an error, object of type. Let's check. Sorry, because we should make it in this, yes. Yeah, we see that it works, yeah. Please be informed that here I wrongly put it bracket, but it should be parentheses, yeah. You see that, very nice. We see that each class is can be seen in the in a different color. For example, this is a class with red, this is a class with green, and this is another class with black. You see that I think it is Setosa that is it can be clearly classified, but you see these two classes have some overlaps, as we can see here, yeah. So let's put the centroids here. Yeah, let's put the centroids here with these points, yeah, with these points. Again, points we want to plot some points. Here the points are k-means result plus centers, and again that's it. Okay, here we'll define the color. Here is the shape of that symbol, and it is the zoom, is the level of magnification. I will show you. Okay, so points here, yeah, iris 2, no, k means cluster, k means result, centers, yeah, centers, and then you see that here the first one all rows, and the second one see again sepal length and sepal width here, and here we have some other parameters. You see, for example, here the color means from 1 to color equal to 1 to 3, and here the type of symbol 8. I will show you what it is, and CX to 2, yeah. You see, it's really nice, you see, yeah. So what is this PCH? It is the shape of the symbol. For example, here you see that it is a star, but according to this website, it's really also very good, and I will use this reference in the later lessons. You see that 8 is here, this symbol, for example, we can use 5. Let's see, we can use 5, yeah. You see, it will change. And CX is the magnification level. For example, if we put it 1, the level, let's again, yeah, the level would be like this, but it's not clear, so it's better that we make it 8. And also, for example, if we put this 3, it means 3 times of magnification, yeah, it would be very big, yes, yeah, and we will see. But here in the text is 2, and also I think it's reasonable, yes. But if it was me, I think also 2 or 7 is also good. 2 or 7 or 19. Let's see, 19. I love this. I love this more. It's really good. Yeah, it's really good. I will make it more clear. I love this, but I think 2 is enough because we don't want to center is very big. Yeah, I love this. So I really enjoyed practicing with you, and I also hope that you also enjoyed this episode. It was until this, yes, we already covered this, and in the next episode we will go through some more details and another machine learning algorithms, clustering, and we will go so on, and hopefully we will go later in the deep learning and so many interesting things. I hope you enjoyed it, and I hope it would be useful and informative for you. And please share your comments and your valuable ideas and with me. It would be my pleasure, and if you like it, please introduce it to your friends and colleagues who are interested. Hope see you in the next videos. Bye.